After 9 long days stuck aboard China's Tiangong space station, following a debris strike that damaged their spacecraft, the three-person crew has finally made it home safely, riding on the backup crew vehicle that arrived later. But here's the twist. This turned out to be one of the worst choices CMSA could have made, because that decision has now left the second crew stranded in orbit. So, why did this happen? Let's break it down in today's episode of Alpha Tech. So it's been just over a week since China's latest space drama kicked off. The Shenzhou 20 crew, 3 taikonauts, had just wrapped up more than 6 months of work aboard the Tiangong space station. They were originally scheduled to return on November 5th, 2025, right after handing over operations to the incoming Shenzhou 21 crew. But only a few hours before undocking, engineers spotted something alarming: tiny cracks on the return capsule's window. They were small, just a few millimeters, but likely caused by impacts from microscopic space debris. And even cracks that small are a huge deal when you're talking about surviving re-entry, with its extreme heat and pressure. In other words, the spacecraft was no longer considered safe to bring the crew home. Instead of taking the kind of risks we've seen on a few emergency Soyuz missions at the ISS, patch it up, pray, and hope for the best, the China Manned Space Agency went with a safer option. They chose to use the Shenzhou 21 spacecraft, the same vehicle that had just delivered the new crew to orbit on October 31st. And to their credit, the plan worked smoothly. Shenzhou 21 undocked from Tiangong at 10:14 p.m. Eastern Time on November 13th, and the crew touched down around 3:40 a.m. on the 14th in Inner Mongolia. It's a familiar landing zone near the Gobi Desert, wide, flat terrain, perfect for ground landings just like Soyuz. It wasn't as gentle as a Dragon splashdown, of course, but the 3 taikonauts came out in good shape. No injuries, no health concerns, and they even appeared shortly afterward in brief interviews with state media. That little moment of relief was really only felt on the ground. Up on Tiangong, a brand new problem was already taking shape, because now the Shenzhou 21 crew is the one stuck in orbit. So, why did that happen? Well, it all comes down to one simple, uncomfortable truth. Tiangong is now left with only one spacecraft, and it's the damaged one, Shenzhou 20. Even worse, the failure was caused by a piece of orbital debris punching into the tiny return capsule window. And that window isn't some decorative piece of glass. On any spacecraft, not just Shenzhou, the return capsule is the most critical section. It's where the crew sits during re-entry. And those windows are made from high-strength composite materials designed to tank insane forces, extreme pressure differences, and temperatures that can reach up to 2,000 degrees Celsius. That's not something you just patch up. In theory, you could try a temporary fix, but in practice, repairing a high-strength composite window is extremely risky and rarely worth it. On the ISS, they've patched hull leaks before, like the 2018 Soyuz incident, using epoxy, metal plates, even cloth, and sealant as a temporary fix. But a window is a completely different story. It's thin, curved, structurally sensitive, and packed with sensors. To even reach it, you'd have to partially dismantle the return module, use robotics, or perform an EVA. And with Shenzhou 20 tightly docked to Tiangong, any attempt to mess with the capsule risks damaging the docking ring or sending vibrations through the station. On top of that, the outer window isn't designed to be swapped out in orbit. It's sealed at the factory. Any fix would need rigorous testing to prove it can survive a 1-atmosphere internal pressure pushing against the vacuum of space. So, let's be honest. Shenzhou 20 is done as a crew-rated vehicle. What China can do, and what they'll likely attempt, is turn it into a test mission, patch it up, send it back down, uncrewed, and gather data on how well it survives re-entry after repair work. That kind of information is extremely valuable for China's future spacecraft development. And that's just the concern about the spacecraft itself. The far more serious issue is the situation the Shenzhou 21 crew is facing right now. They no longer have a lifeboat. If something goes wrong on Tiangong, they have no escape vehicle for an emergency return to Earth. Under normal safety standards, there should always be at least one fully functional spacecraft docked to the station to serve as a lifeboat, something the crew can jump into and return to Earth if anything goes wrong on Tiangong. Which means, in theory, China should have waited until Shenzhou 22 launched and successfully docked before sending Shenzhou 20 back home. If they had done that, The only real downside would have been a busier schedule for 6 astronauts instead of 3. The only trade-off is doubling the consumption of food and oxygen. And honestly, that's manageable. Space stations are usually stocked with a massive reserve of supplies. For example, the ISS always keeps around 2,000 to 2,500 kilograms of food on hand at any given time. In mid-2025, before SpaceX's CRS-32 resupply mission arrived in August, the ISS still had around 2,200 kilograms, enough to feed 7 people for 5 to 6 months, without any new deliveries. Tiangong is smaller, so its reserves are likely lower, but still probably enough to stretch around 3 months, even with a 6-person crew. But here's the part that doesn't add up. China chose to leave the Shenzhou 21 crew up there without a lifeboat, rather than keep all 6 astronauts on the station for a short time. Why? The most plausible reason is that Tiangong simply isn't ready to support 6 people at once. That includes oxygen generation, water recycling, CO2 removal, food production, waste handling, and even the psychological strain of 6 people living in a relatively tight space. Or, another possibility, they're confident they can launch a replacement lifeboat quickly enough that the risk stays within acceptable limits. According to Chinese reports, the plan is to send Shenzhou 22 uncrewed to Tiangong at an appropriate time in the near future to fill the lifeboat gap. The earliest window could be November 21st to 23rd, based on contingency plans, rather than the original schedule in early 2026. This will provide a safe return vehicle for the Shenzhou 21 crew and free up the docking port. CMSA says the spacecraft will launch uncrewed on a Long March 2F from Jiuquan, dock automatically at Tiangong's forward port, carry experimental supplies, and allow the 3 astronauts to use it as their primary lifeboat, while Shenzhou 20 stays in orbit to continue collecting data on the debris incident. Accelerating this launch, potentially 5 to 6 months ahead of schedule, shows the Shenzhou program's flexibility. Backup vehicles are kept at 80 to 90% readiness, and this move should let Shenzhou 21 finish its 6-month mission around April 2026 with minimal disruption. But this isn't just a simple lifeboat shortage. It creates a domino effect across the Tiangong program, forcing CMSA to adjust long-term schedules to maintain operational continuity and safety. Even losing one crewed vehicle like Shenzhou 20 disrupts the regular rotation. The station still needs periodic engine burns to maintain orbit, since all stations naturally lose altitude over time. On top of that, losing a spacecraft forces China to spend hundreds of millions of dollars and 1 to 2 years to produce a replacement vehicle and restore logistical capacity for missions over at least the next decade. On a larger domino scale, moving up Shenzhou 22 by 5 months will ripple into the next missions. Shenzhou 23, originally planned for mid-2026, could be delayed or switched to an uncrewed flight to compensate. Meanwhile, Shenzhou 20 remains docked at the nadir port for data collection, blocking a critical docking port. This means CMSA must prioritize freeing it before Tianzhou 10, the next cargo vehicle, arrives in December 2025. Otherwise, resupply could be interrupted. Overall, China faces billions of dollars in losses and major delays to fix the consequences. You can almost hear them wishing that a SpaceX Dragon could dock at Tiangong, saving the crew for just a few $100 million. The losses would be far smaller. This isn't just a lesson for China. It's a warning for any future space stations, like the proposed Haven Station by Vast Space. For those who haven't heard yet, with NASA planning to retire the ISS in 2030, Vast is racing to launch the first commercial space station, aiming ultimately to replace the ISS. The company recently reached a major milestone in building its first station. Vast, founded in 2021 by Jed McCaleb, focuses exclusively on space stations. Recently, the company launched its Haven Demo probe on a SpaceX Falcon 9 on November 2nd, around 1 a.m. ET, from Launch Complex 40 at Cape Canaveral Space Force Station in Florida. On X, they celebrated the launch with 4K camera footage from orbit and announced the successful deployment of the solar panel system. "What a launch night and team at Vast," CEO Max Haut posted on X. "And thanks for the ride, SpaceX. Haven Demo's mission success has turned us into a proven spacecraft company. The next step will be to become an actual commercial space stations company next year. something no one has achieved yet. Haven Demo isn't just a satellite. It's a 515-kilogram test module operating for 6 months in low Earth orbit to validate technologies for VAST's first full station, Haven 1, which is scheduled to launch May 2026, also on a Falcon 9. Haven 1 isn't just a normal station module. It's designed to give VAST an edge over competitors in the race for NASA's commercial LEO destination. Phase 2 funding rival companies include Axiom Space, Voyager Space, and several others. As of October 29th, the main structure of Haven 1 has successfully completed pressure and load testing, including hatches and dome windows, at VAST's facility in Mojave, California. Next up is final weld inspections, followed by integration into the company's cleanroom. Earlier, the flight certification test was completed at the facility VAST acquired from Virgin Orbit in 2023. These tests included structural load dynamics, pressure checks, and leak inspections. The flight certification test is essential to prove that the station can withstand the conditions required for 3 years of operational life in orbit. Once these tests are wrapped up, Haven 1 will be transported to Cape Canaveral, Florida, for final launch preparations. VAST's official schedule currently targets no earlier than May 2026, though there's still plenty of work to get the spacecraft pad ready. Once in orbit, Haven 1 will host a series of crew visits aboard SpaceX Dragon spacecraft, with each mission lasting roughly 2 weeks before returning to Earth. The station offers about 45 cubic meters of living space, slightly smaller than one of the ISS main modules, but 5 times larger than a Dragon capsule. Looking further ahead, VAST plans to expand with a multi-module station called Haven 2, capable of supporting larger crews and longer missions in the 2030s. And of course, none of this is possible without SpaceX. Haven 1 rides to orbit on a Falcon 9, the crew rotations happen via Dragon, and in the future, Starship could launch entire Haven 2 modules in one go, cutting costs and speeding construction. China just made a move that looks downright reckless. It's as if they didn't think through the obvious consequence. The moment they rushed to bring the 3 Tiangong astronauts safely back home, the next 3 astronauts ended up stranded. And the issue isn't that the China Manned Space Agency used the incoming crew's spacecraft to bring the previous crew back. The real problem is what they left behind. The Shenzhou 21 crew is now sitting on the station without a lifeboat. The only vehicle they have is Shenzhou 20, and that capsule just had its window cracked by orbital debris. It's no longer considered safe for re-entry. China is still trying to figure out what to do with it. Yet somehow, they're keeping a full crew on board with a damaged spacecraft as their only way out. It's basically saying, if anything goes wrong on Tiangong, just climb into the capsule with the broken window and hope for the best. Unsurprisingly, this has drawn heavy criticism from other spacefaring nations, who argue that China isn't taking the health, or even the lives, of its astronauts seriously enough. So, in an effort to rebuild their standing in the eyes of the international community, China quickly introduced a fix for the problem. And what is that fix? Well, China is now getting ready to launch another uncrewed Shenzhou spacecraft to Tiangong. Its job is simple: give the Shenzhou 21 astronauts a proper lifeboat. On top of that, it'll bring along some supplies for science work, new tech equipment, and even a bit of food, like chicken wings, so the crew can keep their little celebrations going up there with the brand new space microwave. This move became clear after an airspace closure notice was issued on November 17th, stating that China is preparing to launch Shenzhou 22 aboard a Long March 2F around the night of November 24th from the Jiuquan Satellite Launch Center in the Gobi Desert. Even so, the China Manned Space Agency hasn't officially released a full rescue plan yet. But here's the timeline. The second crew got stranded on November 14th. That's when Tiangong had 0 lifeboats left. And if the replacement vehicle docks around November 25th as expected, that means China is taking roughly 10 days to restore a safe escape option for their astronauts. Well, rescue might not even be the right word, because the Shenzhou 21 crew will still continue their mission for more than 5 months. The real issue is that the station must have a docked spacecraft at all times, both to boost its orbit and to serve as an emergency ride home if something goes wrong. And with this move, China is highlighting just how quickly they can respond to a problem. The contrast is pretty stark compared to the Starliner situation, where astronauts Suni and Butch remained stuck on the ISS for nearly 9 months. But hold on a second, can we really compare these two situations? One was caused by technical flaws in Starliner, while the other was triggered by a completely external factor, a piece of orbital debris punching through a window. Of course, the causes have nothing to do with how each agency chose to handle the problem. So let's talk about NASA's response first. Right after discovering the serious helium leaks and thruster issues on Starliner, this was around June 2024, NASA didn't sit around waiting. They acted fast and decisively. But then, why did it still take 9 months to bring Suni Williams and Butch Wilmore home? It's simple. NASA puts astronaut safety above everything else, especially when those astronauts have dedicated decades of their lives to the space program. That's why Administrator Bill Nelson and Associate Administrator Jim Free made it official. Even though Starliner still had a 96 to 97% chance of returning safely, NASA wasn't willing to accept the remaining 3 to 4% risk. So they completely removed Starliner as a landing option. After that, NASA immediately worked with SpaceX to reconfigure the Crew 9 mission. The original plan was to launch 4 astronauts. Now it would only launch 2, Nick Hague and Alexander Gorbunov, leaving 2 empty seats for Suni and Butch. At the same time, NASA asked SpaceX to extend the docked Crew 8 Dragon by nearly a month, just to make sure the ISS always had a lifeboat available, exactly the situation Tiangong is dealing with recently. But because SpaceX's launch schedule was already packed solid, they couldn't simply accelerate the mission. Everything had to follow the existing plan. And since the ISS has plenty of capability, oxygen production, water recycling, long-term food supplies, NASA agreed to wait. So it wasn't until March 2025 that Dragon Crew 9 finally brought everyone home. And after that, SpaceX's and Elon Musk's reputation shot through the roof. Meanwhile, China cut their station crew from 6 down to 3 as fast as possible, not because the mission required it, but because they weren't confident their system could safely support that many people for long. Bringing Shenzhou 20 home so quickly didn't show careful planning, it showed how desperate and risky their approach was. That's why, even though both situations involve rescue missions, the outcomes couldn't be more different. SpaceX got praised. Even former President Donald Trump stepped in, saying, Elon is able to do that with his genius. Number 1, they have to get better. I expect to welcome Wilmore and Williams to the Oval Office once they get better. China, on the other hand, got nothing but harsh criticism. And honestly, NASA's slow but safe approach didn't disrupt anything. Suni and Butch themselves said they never felt stranded. They treated it as a once-in-a-lifetime experience, becoming the longest-staying U.S. astronauts in orbit. And on top of that, Trump even joked that he'd personally pay their salaries during the extra months. China's quick response was impressive in terms of speed, but it crossed into being reckless. And while many ordinary citizens might disagree with the government's approach, they don't exactly have the freedom to say it out loud. You know what I mean. According to an official from China's Manned Space Engineering Office speaking on November 15th, the Shenzhou 22 spacecraft, originally scheduled to carry the next crew to Tiangong in April or May of 2026, will now launch without astronauts. He noted that preparations are already underway, and this uncrewed vehicle will bring up food, daily supplies, and new equipment to keep the Shenzhou 21 crew going. With the Shenzhou 20 crew staying far longer than planned, Tiangong supplies are getting tight, and the life support systems are feeling the extra load, so that pretty much confirms everything we've just talked about. At this point, the timeline for launching this backup Shenzhou depends on a whole list of variables. The readiness of Launch Complex 921, the same pad that just sent up Shenzhou 21, local weather conditions, range safety, orbital mechanics between Jiuquan and Tiangong, and the technical status of both the rocket and the spacecraft. Even if the hardware is good to go, China still has to wait for the right orbital alignment, which means several extra days of delay are entirely possible. As for Shenzhou 20, China plans to deorbit it sometime later. In theory, the spacecraft is still attached to the station and accessible, but CMSEO has already concluded it's not safe enough to bring anyone home. In a statement released on November 14th, the agency said that after reviewing images, running simulations, checking the design, and performing wind tunnel testing, they found a small crack on the outer heat-resistant glass of the crew cabin window. The most likely cause, an impact from orbital debris. Because of that crack, the vehicle no longer meets the safety requirements for a crewed return flight. Instead, Shenzhou 20 will remain in orbit to support a series of planned experiments. That crack, sitting on the outer thermal layer of the window, poses a serious risk. If it spreads or breaks during re-entry, the inner layers could be exposed to superheated plasma that could compromise the window structure and lead to depressurization of the spacecraft, a life-threatening scenario. From there, the comparison becomes almost ironic. In 5 years of Crew Dragon flights, SpaceX has never faced a problem like this. The closest incident happened during the Crew 2 mission in 2021, when a piece of debris, roughly the size of a softball and traced back to Japan's H-2A rocket, passed within just 1 to 2 kilometers of the capsule as it approached the ISS. The crew had to suit up and strap into their seats just in case, but nothing happened, and ISS controllers simply adjusted the station's orbit to steer clear. And even if a strike had occurred, Crew Dragon is built with layered Whipple shielding, a dual-wall protective system designed to absorb impacts from tiny micrometeoroids and small debris under a millimeter in size, so the odds of serious damage were still extremely low. Meanwhile, across the space industry, other rocket programs were making headlines of their own. On November 17th, Blue Origin's New Glenn booster was safely transported back to Port Canaveral after its first-ever successful landing. As soon as it touched down, Jeff Bezos celebrated like a child returning home after years away, posting a flurry of photos on X, basically showing off to Elon Musk. Given their rivalry, it's clear Bezos wants Musk's recognition. And Blue Origin isn't stopping there. They want to cement their case even further. How? By reusing that very booster for the next New Glenn launch, currently planned for early next year. Coincidentally, this timing lines up with SpaceX's first launch of Starship Block 3. It almost seems like Blue Origin is pressuring itself to fly before SpaceX. Historically, the company has struggled with these milestones, and it's still unclear if this time will be any different. That said, there's a real concern. Refurbishing a recovered first stage could push back the next launch schedule. New Glenn was designed for a fast turnaround, 2 to 3 weeks between flights, but nobody expected that pace right out of the gate during the first refurbishment cycle. Still, Bezos' rocket company believes the risk of a short delay is worth it. Even slipping a few weeks probably won't significantly impact their long-term flight plans. The upcoming New Glenn mission is expected to carry the Blue Moon Mark 1 lander, an uncrewed spacecraft built to test key systems for NASA's Artemis 5 mission in 2029. Launching Mark 1 in early 2026 would be ideal, but if the schedule slips, the mission isn't in jeopardy. In fact, CEO Dave Limp has said the lander could be shifted to New Glenn's 4th flight if necessary. The message is clear. No rush, and development progress remains tightly under control. Another concern raised by critics is the launch cadence. Could delays prevent Blue Origin from ramping up to a reliable flight rhythm? But that misses a more fundamental point. You can't maintain a cadence without hardware. At the moment, the company hasn't committed to a fixed number of New Glenn launches for 2026. Instead, this year's focus is on building up a reserve of boosters. According to Dave Limp, Blue Origin aims to produce around 20 first stages per year, making sure the infrastructure is in place before making any promises about a rapid launch cycle. As he put it, that's the next step we need to sit down with the team on. Orion is perhaps the most troubled spacecraft ever built. It was born under the Constellation program launched in 2005 during President George W. Bush's administration, with a bold goal to restore America's leadership in space exploration. The plan was to pair Orion with the Ares Wing and Ares Avith rockets, creating a powerful and safe launch system for long-duration missions to the ISS, the Moon, or even Mars. In other words, it was designed to be a multi-purpose spacecraft, much like what Starship aims to be today. But that bold dream quickly ran into major trouble. By 2010, the program was canceled by the former President Barack Obama due to its enormous cost, projected to exceed $100 billion, along with slow progress and concerns raised by the Congressional Budget Office that it simply wasn't cost-effective compared to commercial alternatives. Despite billions already spent, Orion was on the brink of being scrapped entirely. It was only saved thanks to Congress and lawmakers who insisted on keeping NASA's domestic crewed spaceflight capability alive. $100 billion was a staggering number, but at the time, it still seemed reasonable compared to the Space Shuttle program, which had cost around $200 billion in total, and that's probably why Orion managed to survive. After being frozen, Orion underwent a major restructuring starting in 2010. It was redirected into NASA's new Space Launch System and the Artemis program, focusing on crewed missions to the Moon. By 2014, Orion finally made its first uncrewed test flight, Exploration Flight. Test 1 launched atop a Delta IV Heavy rocket. It reached an altitude of 5,800 kilometers, testing its heat shield and parachute system, successfully proving it could survive the intense re-entry conditions of a lunar mission. That's why, 8 years later, Artemis the Throne in 2022 became such a huge success. Powerful, reliable, and tested, there's no denying Orion's capabilities. But the problem has always been the cost. Since 2006, Orion has consumed around $20. $4 billion, averaging over $1.1 billion per year, mostly due to technical challenges and repeated design changes after the collapse of Constellation. And now, the pressure is building again. In the FY 2026 budget proposal, President Donald Trump's administration has suggested cutting NASA's funding by 24%, from $24.8 billion down to $18.8 billion, aiming to phase out both SLS and Orion after Artemis 3. The planned shift focused toward cheaper commercial spacecraft to save costs and push private competition forward. With that shift in strategy, attention naturally turns to one company that's already proven it can deliver, SpaceX, and its Dragon spacecraft. Why? Since 2020, Dragon has completed over 50 missions carrying both crew and cargo to the International Space Station with a success rate of 99%. Can Boeing's Starliner say the same? Definitely not. And when it comes to cost, the difference is night and day. Developing Dragon only cost around $3.2 billion, of which $6 billion came from NASA's contract. That's why every launch is far cheaper than a spacecraft that has already burned through $20 billion and counting. But to be fair, flying to the ISS and flying to the Moon are two completely different challenges. Going beyond low Earth orbit would require some serious upgrades, especially for the Crew Dragon. Spaceflight architecture at its core is all about energy cost, or what engineers call delta V, the change in velocity needed for a mission. For a round trip to the Moon, you need roughly 6 km per second of delta V. Right now, Crew Dragon only has about 2.5 km per second. From its Draco thrusters, not nearly enough to make the journey. So, upgrading the propulsion system would be the first step. Next, there's the heat shield. When returning from lunar orbit, re-entry speeds reach 11 km/s. But the good news is, Dragon's Pika X heat shield has been designed for exactly that speed since 2010. Meanwhile, Orion uses Avcoat, a heavier, older material from Apollo, which worked in EFT-1 and Artemis-1, but suffered 40 to 60% ablation, was severely charred, and could not be reused. Pika X, by contrast, is 30% lighter than Avcoat, has passed 11 km/s plasma arc jet tests on Earth, and is designed for around 3 to 5 reuses. So Dragon doesn't need a new heat shield, just a real flight test. Then there's the life support system. The spacecraft must keep astronauts alive and comfortable for the entire trip. Reports suggest that Dragon can currently support 4 crew members for about 7 to 10 days, as demonstrated during Polaris Dawn, a 5-day private mission, commanded by Jared Isaacman. That might not be enough for a full lunar mission. For comparison, Apollo was rated for 14 days, Orion for 21, and most Apollo missions lasted between 8 and 12.5 days. So technically, Dragon could make it work with a 2-person crew, leaving little room for error. To achieve that, its life support capacity, including oxygen water and CO2 scrubbers, would need to be expanded, which of course means more weight and less cabin space. Dragon's pressurized volume is only 9.3 cubic meters. It's small, but it can still fit up to 7 people. For a lunar mission, optimizing that space for just 2 astronauts would make sense, leaving extra room for supplies and critical systems. In short, if SpaceX can overcome the Delta V challenge and strengthen Dragon's life support endurance, the Crew Dragon could genuinely become a short-term lunar solution, faster and far cheaper than anything NASA has today. So, let's imagine it has been upgraded. How exactly would Dragon replace Orion for a lunar launch? Of course, if Orion is cancelled, Dragon can't just ride on SLS. The docking interface is completely different. The only logical launch vehicles would be Falcon 9 or Falcon Heavy. And between the two, Falcon Heavy is the clear choice for sending Dragon toward the moon. Here's how it could work in the simplest and most realistic way. Falcon Heavy, powered by 27 Merlin engines, produces over 22 million newtons of thrust, enough to lift 63 tons into low Earth orbit about 200 kilometers high. A fully loaded Dragon, even with its protective fairing and adapter, weighs less than 16 tons. That's barely a quarter of the rocket's capacity, plenty of margin to spare. Once in low Earth orbit, Falcon Heavy's upper stage, optimized for vacuum, could reignite to accelerate from 7.8 km/s to roughly 11 km/s, the speed needed to escape Earth's gravity and head for the moon. This critical burn, known as translunar injection, could be done entirely by the existing second stage, no extra boosters, no complex refueling steps. As Dragon approaches the moon, its Draco thrusters could take over for fine-tuning and orbital insertion. They're small, yes, but more than capable of making precise adjustments to guide the spacecraft into a stable lunar orbit. Compared to NASA's SLS, which can haul up to 95 tons to low Earth orbit, Falcon Heavy is lighter and simpler, but also far cheaper and far more reusable. While SLS needs an additional upper stage to push Orion toward the moon, Falcon Heavy uses its standard second stage, a design that's already been tested and proven in multiple missions. In other words, Dragon on Falcon Heavy wouldn't just be possible, it would be elegant, efficient, and affordable. Continuing with the mission after Falcon Heavy successfully placed Dragon into lunar orbit, the capsule begins a series of fine orbit adjustments using its small Draco thrusters. The goal? To precisely match its orbital phase with the Starship HLS, which had been launched separately. This orbital choreography takes hours. NRHO, or Near Rectilinear Halo Orbit, is massive, and every maneuver must be calculated to avoid wasting delta V. The crew checks their laser radar, star tracker cameras, and relative navigation systems to prepare for the rendezvous, closing the gap from hundreds of kilometers down to mere tens of meters. As the two spacecraft approach, Dragon switches to proximity operations. Using LiDAR and cameras, it's guided partially by ground control, but mostly operates autonomously, docking through NASA's NDS mechanism, the same system it uses at the ISS, or with Starship in LEO. Once hard dock is confirmed, the airlock pressure is equalized. The crew opens the hatch, inspects the seal, and transfers to Starship HLS. While waiting for the landing window, often several days because NRHO only aligns near the moon periodically, Dragon maintains a stable orbit with minimal maneuvers to conserve propellant. The crew also runs checks on backup systems, including the Super Draco abort engines, which in this scenario could bring them straight back to Earth if needed. Starship HLS then undocks from Dragon, uses its Raptor engines to lower itself into low lunar orbit, and performs a soft landing with methane oxygen thrusters. The surface mission lasts about 6 to 7 days moonwalks to collect samples, deploy scientific instruments and test rovers or ISRU technology to extract water from ice. Once complete, the ascent stage of Starship launches back to NRHO rendezvous and docks with Dragon again. The crew transfers back carrying roughly 100 kilograms of precious lunar samples, while the ascent stage is either left behind or disposed of into a heliocentric orbit to prevent space debris. Finally, Dragon fires its trunk service module to execute a trans-Earth injection, burn a powerful push using Draco thrusters that sends them out of lunar orbit and homeward, a journey of 3 to 4 days. Sounds exciting, but that old architecture is still pretty complex. Dragon has to dock with Starship multiple times. So, what if Elon wanted a much simpler setup? That plan is essentially the simplified Starship HLS currently in development to meet Artemis requirements. It would launch from Starbase with a Crew Dragon either inside its cargo bay or mounted on the nose, taking advantage of Starship's 150-ton LEO lift capacity to carry lunar fuel and surface equipment. Sure, there's a trade-off in payload mass since HLS has to carry Dragon too, but the setup is much simpler. Once Starship reaches lunar orbit via translunar injection, it automatically releases Dragon into a stable parking orbit. The crew stays on Starship to descend to the lunar surface for a few days of activity. EVAs deploying the Viper rover, testing ISRU oxygen production, and completing core Artemis objectives. After the mission, Starship lifts off rendezvous with Dragon in orbit using the APAS docking system. The crew transfers to Dragon and Dragon heads straight back to Earth, splashing down off Baja, just like a typical ISS return. Launch Pad 1. Once the stage for those fiery static fire tests of both Super Heavy and Starship. Once the place where we witnessed 11 legendary flights. Once the pad that gave us those breathtaking booster catch attempts is now being torn apart by SpaceX in the most literal sense. But this isn't reckless destruction. What you're seeing is a full clean out to prepare for a major transformation next year. It's not just the vehicles getting upgraded, the pad is too. The plan is to rebuild Pad 1 into a brand new version, removing the old 6-leg OLM so SpaceX can install a new integrated OLM design that will better support the upcoming Starship version 3, expected to debut early next year. And this new OLM structure is a massive box-shaped system, practically the size of a storage building, so to fit it in, SpaceX has to strip out the entire old OLM and the previous water deluge system as well. That teardown kicked off almost immediately after Starship Flight 11, and it's been about 5 weeks now. Each week the old OLM looks less like a launch mount and more like a pile of twisted steel. Last week, crews removed most of the upper section of the OLM ring and began cutting straight through the lower support beams and the remaining structures connecting the 6 legs. Some pieces were lifted out cleanly, others were dropped straight onto the dirt pad below with a heavy thud. It's obvious they don't plan to reuse anything. Most of this metal will likely be sold off to a recycler and melted down for raw material. Even the cable chain, the one that routed power and comms to the chopsticks, has already been detached from Tower 1 as crews strip away the old systems. And Sunday marked the biggest jump in progress yet. Workers used a crane to rip off the staircase engineers, once used to climb onto the mount. A pretty clear sign they no longer need to get up there to cut or remove anything. Right after that, one of the 6 massive OLM legs was pulled over and crashed down. What's left of the old mount now looks like some kind of steel Stonehenge. This week, the teams are expected to take down another 2 or 3 legs, and by next week, the whole structure should be completely gone. Once everything is cleared, they'll start burying the old deluge plate, the steel water spray pit beneath the OLM. It's still buried under debris from the teardown, but once exposed, it'll be removed entirely. The new pad won't reuse any of it because SpaceX is switching to a next-generation's deluge system, with water spraying from multiple directions and at much higher flow rates. Basically, it's the same setup we've been seeing them test over at Pad 2, lately huge sprays shooting straight into the air. And no, the engineers aren't just playing with water like kids. They're checking flow accuracy, making sure nothing's clogged, and confirming the pumps are behaving the way the controllers expect. As for Pad 1, there's still a lot of work ahead. Once demolition wraps up, they'll need to install the new flame trench, build out the advanced deluge system, assemble the new OLM, refurbish the chopsticks on the tower, reintegrate all the plumbing and propellant pumps from the nearby tank farm, and then run hundreds of system tests before the pad is ready to debut again for the rest of us. And if you really want a clear picture of the kind of work SpaceX still has to get through, you don't have to look far. The perfect example is already playing out at LC-39A. See, SpaceX has big ambitions at the Cape too. In fact, their Starship pad here is expected to come online before Pad 1 at Starbase is even finished. Why? Well, around November 5th, SpaceX rolled out the brand new launch mount, the same next-gen mount that Pad 1 will eventually use. It's the one with Stack Me written on the heart-shaped plate. They transported it all the way from Roberts Road to LC-39A and lifted it into the flame trench using that giant crane. That single operation marked a huge milestone. The mount is now structurally in place. And it gets better. Just yesterday, Kiko Donchev, SpaceX's VP of Launch, dropped a few stunning photos on X confirming that the pad is really starting to take shape. He shared shots taken from inside the flame trench, looking up at the mount as the crane locked it down. The SpaceX Starship pad at 39A is really starting to take shape. The team moved and stacked the launch mount to the pad a little under 2 weeks ago, he wrote. Then he followed it up with, "Can't wait for the first V3 Starship launch, and soon after, the first Starship launch from the Cape." When Kiko says it like that, you know things are on the right track. Right now, the Starship pad at LC-39A has cleared the heavy construction phase and is moving into full system integration, and honestly, the overall progress looks solid. The giant launch mount has been locked into place since early November, and the tower with its chopsticks has been finished since 2022, just waiting for the day it starts catching boosters for real. What's left is mostly the tank farm and the cooling systems. The tank farm has been moving a bit slower, since SpaceX prioritized the big structural work first, but all the hardware is already in motion. The liquid methane tanks, the liquid oxygen tanks, and even the 7 massive deluge water tanks are either on site or being shipped by barge toward the turning basin. Once they get the green light, installation will ramp up fast. The deluge system at 39A is also a major upgrade compared to Starbase. The entire water manifold, the methane hood, and the quick disconnect plate are already integrated directly into the launch mount, and all the pumps and pipes sit above ground now, making maintenance way easier. On the regulatory side, the FAA's draft EIS has been out since August 2025. Public hearings are done, and the final approval is expected before the end of the year, with permission for more than 40 launches annually. That clears the path for full pad testing by late 2025, and the first Starship launch from Florida is looking very realistic for spring 2026, using the new V3 vehicle Kiko mentioned, mainly for Starlink deployment and orbital refueling tankers. One small twist, the Gigabay at the Cape isn't producing Starships yet, so there's a good chance we'll see SpaceX roll a full Super Heavy and Starship stack out of Starbase, load it onto a ship, and sail it all the way to Port Canaveral. That alone would be a spectacle. Bottom line, the tank farm is the only temporary bottleneck, but everything else is ready to accelerate the moment SpaceX decides. And with progress moving this fast, from Texas to Florida, it all points to one thing: getting ready for the debut of Starship version 3. So, how's the vehicle itself coming along? Well, here's the good news. Ship 39, the very first Starship V3 prototype, just had its aft section installed on the 16th. That's the final major piece for the exterior structure, which means it won't be long before SpaceX rolls it to the Massey test site for its first cryo runs. Meanwhile, Booster 18 is already fully stacked, but still sitting quietly inside Megabay 1. It looks like SpaceX is waiting on something, most likely the finishing touches on the ceramic heat shield system. Recently, the team removed the heat shield tiles from Booster 17 out at Rocket Garden, likely so they can reuse them on B-18. That's pretty much the nail in the coffin for B-17. It won't be flying again. Rest in peace, buddy. Over at the Massey Outpost, the Booster 18.3 test tank went through another round of testing as the Block 3 booster verification campaign continues, and there was a bit of unexpected chaos at the construction site. The Western Tower crane glitched out and started spinning for hours. It even happened a second time not long after. These cranes are designed to weather vane with the wind, but they're definitely not supposed to spin like a fidget toy. Nobody's quite sure what went wrong there. Now let's move over to McGregor, Texas, where engine activity is still in full swing, and honestly, it remains one of the most critical pieces behind every Starship mission. This is where the Raptor engines, the muscle behind Starship, get fired, tuned, pushed, and sometimes pushed a little too far before they ever fly. Recently, one of the Raptor 3 engines actually exploded during a test, and while seeing an engine blow up sounds alarming, especially at this stage of the program, it's really not that shocking. What is unusual this time is when it happened. The failure occurred during engine startup, not during a long-duration static fire, which is normally where we see issues show up. A startup failure always raises natural questions. Was it a bad engine? A manufacturing glitch? Maybe a new design tweak gone wrong? But right now, the odds of this being a systemic problem are pretty low. Raptor engines have been through an insane amount of testing, and earlier versions have already proven to be surprisingly reliable. So, the situation likely comes down to two possibilities. Either this was a one-off issue with a single engine, or SpaceX intentionally pushed the startup sequence way past the safe zone to see where things break. And honestly, knowing SpaceX's testing philosophy, the second explanation is the more likely one. Next year, Raptor 3 is going to carry some of the riskiest Starship missions yet. Flight 12, for example, will require the first ever in-space restart of a Raptor 3, and that's a huge milestone. After that, Starship missions will need precise engine restarts for deploying payloads, setting up the orbital refueling system, and pulling off the complex two-stage landing sequence. All of that depends on the engines being able to shut down and reliably come back to life. And we've seen in previous flights that restarts after long burns can still be tricky. So proving this capability in real-world conditions is absolutely essential. That's why these standalone engine tests at McGregor matter so much. Engineers can push Raptors right up to, and sometimes beyond, their operational limits in a fully controlled environment. By deliberately breaking the startup sequence, SpaceX gets priceless data on where the margins really are. That lets them fix issues long before they ever show up during an actual mission. And the fact that SpaceX hasn't made any official comments about this test pretty much tells you everything. They see it as just another day in the development process, nothing more. And the timing lines up, especially with SpaceX, pushing hard to stay on track for its lunar timeline. A leaked internal email suggests that the uncrewed lunar landing demo is targeted for June 2027, with the first crewed landing following in September 2028. The orbital refueling prep missions are scheduled to begin as early as June 2026. Leading up to all of that, Flight 12 in January will focus heavily on in-space engine restarts, while several missions in the first half of the year will involve payload deployment and the full two-stage landing sequence. SpaceX might have to let a few Starship team members go after someone leaked an internal document outlining the scheduled plans for HLS to Politico. Audrey Decker, a reporter specializing in space and emerging technology for Politico, was behind the article, which she also shared on X, along with screenshots of the internal memo previously sent to her via email. She even claimed to have obtained the SpaceX internal document and revealed the updated provisional timeline for HLS. According to the leak, the schedule includes the propellant transfer demonstration in June 2026, an uncrewed lunar landing demonstration in June 2027, and the first crewed lunar landing for Artemis 3 in September 2028. The document wasn't posted in full, of course. It's normally only shared within a tight circle of HLS department heads, senior Starship leadership, and key project engineers, totaling fewer than 300 people with access to the latest version. It's stored on SpaceX's internal Confluent/SharePoint system, watermarked and tracked for every viewer, which is why only the content was shared publicly, not the file itself. So far, SpaceX has remained mostly silent on the leak, which isn't surprising since they usually handle these matters quietly to avoid a fuss. But in this case, the fuss is understandable. The schedule has already slipped from the initial plans, so let's break it down. According to the leak, SpaceX won't run the propellant transfer demo, refueling one Starship from another in orbit, until June 2026. That timing actually makes sense, as orbital refilling requires at least 2 vehicles ready on the pads and launched separately. By early next year, LC-39A should be fully operational, making this part of the timeline reasonable. The uncrewed lunar landing, meant to test the landing system and operations, won't happen until June 2027, an entire year after the orbital refueling demo. Naturally, this disappoints some people, especially since back in early August, Musk promised on X a slight chance of Starship flight to Mars crewed by Optimus in November or December next year. A lot needs to go right for that. If we can't even get Starship to the moon by 2027, sending Optimus to Mars in 2026 seems impossible. The one-year gap also highlights high risk. After the refilling demo, SpaceX will need at least 6 to 9 months to integrate data, finalize the HLS Block 3 design, ensure the landing system works with the new hot staging ring of the booster, sync with Raptor engines, and conduct repeated orbital tests, probably 4 to 5 tanker flights. And so far, no Starship has completed a full orbital flight, which makes the uncrewed lunar landing in 2027 aggressive. If the refilling demo fails the first time, a crewed flight could easily slip to 2028 or 2029. Still, the key takeaway is that the leaked document already projects the crewed lunar landing for Artemis 3 around September 2028, a date that might worry some, but in reality, 2028 is exactly the timeline SpaceX is aiming for, only a year behind NASA's 2027 target. And when you look back at NASA's own history, 2028 is insanely fast. Apollo took 7 to 8 years to go from contract signing to boots on the moon from 1962 to 1969. HLS, from 2021 to 2028 is just 7 years, and SpaceX has to build everything from scratch: Super Heavy, Starship Depot, Starship Tanker, the entire orbital refilling architecture, the whole stack. That pace is incredible, and the cost difference is almost ridiculous. Apollo burned through about $25.4 billion back then, equivalent to roughly $257 to $280 billion today. Meanwhile, NASA is paying around $4 billion for 2 Starship HLS contracts. It's not even in the same universe. Delaying a year isn't a weakness, it's breathing room. It lets SpaceX slow down just enough to build something that truly works. And remember what they're building: a breakthrough vehicle, bigger than anything humanity has ever tried to send into space, a ship meant to carry our dreams of living on the moon and Mars. So, does a 1-year delay really matter? Honestly, not at all. If you agree, drop a "Go SpaceX" in the comments to show your support. Actually, SpaceX plans to roll all of these leaked dates into a single integrated master schedule that they'll deliver to NASA in December. After that, the company will work with NASA to formally revise the current contract and lock in the new timeline. Until then, the document makes one thing clear: these dates are estimates, not approved contractual milestones. And of course, everything hinges on how well Starship version 3 performs next year. If flies smoothly with fewer failures, reaches orbit, and nails the orbital refilling demo early, then September 2028 won't be the date of Artemis 3. It'll be the month everyone is still celebrating Starship HLS's successful moon landing, marking humanity's return to the lunar surface for the first time in more than 50 years, while effectively shutting down China's hopes of beating the US in this new space race. Interestingly, this updated timeline lines up pretty closely with what NASA's Aerospace Safety Advisory Panel, ASAP, estimated back in September. That assessment came after 3 of its members visited SpaceX's Starbase facility in Boca Chica, Texas, where they met with senior SpaceX leadership. They were impressed by the company's production pace and overall operations, but still concluded that the schedule for the human landing system faces significant challenges. ASAP meets privately with NASA and other officials every quarter, and afterward holds a public teleconference to share their insights. About a week after one of those sessions, panel members Paul Hill, Kent Rominger, and Charlie Precourt traveled to Starbase. Hill is a former NASA flight director and mission operations directorate-chief at Johnson Space Center, while Rominger and Precourt are both former astronauts. Hill explained that their primary task was to evaluate whether Starship HLS could realistically be ready for Artemis 3 in mid-2027. The mission meant to return American astronauts to the lunar surface for the first time since Apollo. At Starbase, they met with Bill Riley, SpaceX's VP of Starship Engineering, Artie Matthews, the Starship HLS Program Manager, and Bill Gerstenmaier, VP of Build and Flight Reliability. They were genuinely impressed by what Hill described as SpaceX's self-sustaining, multidisciplinary brilliance, especially the company's strategy for accelerating production, speed, and reliability. Still, despite the praise, they found the chances of HLS being ready in 2027 to be doubtful. As Hill warned, the HLS schedule is under real pressure and could slip several years past the 2027 Artemis 3 target. Cryogenic propellant transfer, absolutely essential for the mission, simply has to work. But getting there depends on several things: Starship version 3 coming online on time, a clean demo of the V3 tanker and depot, both major upgrades and meaningful performance and reliability gains on the Raptor V3 engine. And he isn't wrong. The core of SpaceX's entire HLS architecture comes down to one thing: Starship's reusability. That's the heart of the orbital refilling strategy. Why does it matter so much? Because a full lunar mission will require roughly 7 to 10 tanker flights to low Earth orbit, transferring cryogenic propellant into a depot, and then HLS will drink from that depot for the trip to the moon. If those tankers had to fly expendable, the cost would explode back to Apollo-era levels, burning mountains of money for a single mission. That completely goes against SpaceX's philosophy. And there's another issue. We still haven't seen a fully built HLS yet, let alone one ready for flight tests. But don't worry, SpaceX has confirmed that the first Starship HLS vehicle is now being assembled, fully outfitted with avionics, power systems, life support hardware, communications gear, and thermal control components. This initial module will serve as the backbone for a whole series of integrated tests and astronaut training activities leading up to the first crewed lunar landing. According to SpaceX, the HLS team has already completed 49 major milestones, covering everything from subsystem design to ground support infrastructure and mission operations. Under the Option A contract, signed in April 2021 and worth about $2.89 billion, NASA laid out 64 development milestones, each paid only after successful completion. In other words, SpaceX has knocked out roughly 77% of the program in just 4.5 years. That's far ahead of the typical pace in government aerospace. SLS, for example, took over a decade to get through a similar set of milestones. With only 15 major tasks left and nearly 2 years to go, SpaceX has more than enough runway to finish. Taken together, these milestones show one thing clearly. The program is moving steadily, from hardware to systems to full mission operations, all pointing toward humanity's long-awaited return to the lunar surface. And that's where the bigger picture comes in. Now, picture this. If SpaceX and the Artemis program get Americans back to the lunar South Pole in 2028 or 2029, a year or two before China, then it's no longer about who lands first. It becomes a much bigger race. Who secures the prime ice deposits and gets to shape the rules. At the South Pole, only a handful of permanently shadowed craters actually contain significant water ice. Whoever arrives first gets the privilege of conducting detailed surveys, picking the prime locations, and immediately deploying mining equipment, nuclear reactors, and fuel production systems. With Starship carrying 100 to 150 tons per flight, the U.S. could establish a true permanent outpost in just a few missions. Meanwhile, China would need years to match that scale, since their current lunar landers aren't much more capable than Blue Origin's first-generation Blue Moon. And that's when the Artemis Accord's safety zones become real. The U.S. could legitimately ask all other missions to stay tens or even hundreds of kilometers away to avoid dust contamination and radio interference. It wouldn't be territorial ownership in name, but in practice, it's a soft form of control that still fits within the 1967 Outer Space Treaty. China, which refuses to sign the Artemis Accords, would absolutely see this as disguised land grabbing. Their likely response? Attempting to land close enough to challenge the rules, accelerating their own base construction, and publicly declaring their own set of norms. Yes, Starship and New Glenn aren't just heavy rockets. They're both true super heavy launch vehicles. And the moment they entered the scene, SpaceX and Blue Origin were locked into a no-nonsense rivalry. Competition is always healthy. Every time one side scores a breakthrough or hits a new milestone, both companies benefit. They push each other forward, day after day. And just recently, after a long 10-month wait since New Glenn's first flight, Blue Origin finally launched its second mission on the afternoon of November 13th, just a few days ago. And to be fair, the results were well worth the wait. The company chalked up 2 major achievements, a successful booster landing and the flawless deployment of a NASA support satellite for Mars research. Both achievements are undeniably impressive, especially considering Blue Origin pulled them off on only New Glenn's second flight. But here's the reality. These are things SpaceX has been doing for years and doing constantly, every week, not once in a blue moon. It's a reminder that hitting a milestone isn't just about celebrating. It's about understanding where you actually stand in the race. And speaking of that race, let's talk about the landing. There's no denying it. New Glenn's Never Tell Me the Odds booster stuck a beautiful touchdown on the Jacqueline drone ship. It was a solid success, Of course, you can't directly compare it to Falcon 9. One is a heavy lift rocket, the other is a medium lift workhorse. But what happens when you compare it to Starship's landing method? That's where things get interesting. Before we get to Starship's approach, let's start with New Glenn's landing method, the classic drone ship touchdown. It's a technique that feels familiar, largely because SpaceX has been refining it for nearly a decade. New Glenn's first stage stands about 57 meters tall and runs on 7 BE-4 engines burning liquid methane and oxygen. The idea is simple in theory. Bring the booster back from the edge of space and set it down vertically on Jacqueline, a 116-meter autonomous barge stationed hundreds of miles off Florida's coast. On the NG-2 mission, November 13, 2025, the booster, never tell me the odds, nailed its landing just 9 minutes after stage separation. That's especially notable considering its first attempt back in January ended in a breakup at Mach 5.5 due to re-entry instability. The booster uses 4 actuated aerodynamic surfaces to keep itself stable during atmospheric descent, with strakes generating lift and helping fine-tune its cross-range path. As it approaches the drone ship, the engines reignite to bleed off speed from thousands of kilometers per hour to just a few meters per second. 6 hydraulic landing legs deploy automatically to absorb the final impact, while GPS and radar guide the booster onto a platform that's literally moving with 3 to 5 meter ocean swells. The real challenge isn't the rocket, it's the ocean. Wind, waves, and a drifting target force the guidance software to be incredibly precise, something SpaceX only mastered after dozens of attempts with Falcon 9. But even when everything works, this method comes with baggage. A drone ship has to be towed into position, operated remotely, and later hauled back to port for booster recovery. That can take days, sometimes weeks. It also requires a sizable crew, tugboats, support ships, and a long logistics chain. All of that adds cost, time, and complexity, things that don't scale well if your goal is rapid, airline-style reuse. Now, let's switch over to Starship's landing method with Mechazilla, a completely different level of ambition. Instead of touching down on a drone ship, the Super Heavy booster, a 70-meter monster weighing more than 3,000 tons when fully fueled and powered by 33 Raptor engines, gets caught by 2 giant mechanical arms on the launch tower at Starbase. This system had its first successful catch during Flight 5 on October 13th last year. Funny enough, the same exact date New Glenn pulled off its first landing, but the Mechazilla catch is on a whole different level of difficulty. Right after hot staging at about 70 kilometers up, the booster fires a cluster of 13 Raptors to start bleeding off speed. Then it transitions to just the 3 center engines, hovering precisely over the tower while those massive chopstick arms, each weighing hundreds of tons, close in. Using hydraulic actuators and laser sensors, the arms grab onto the load points under the grid fins. And all of this happens in around 7 minutes from separation to catch. The required precision, less than a meter, with the booster dropping in at roughly 5 to 10 meters per second. The Mechazilla tower itself is a 145-meter steel giant. Thanks to its sheer mass and built-in shock absorption, it can handle the enormous forces involved. On top of that, SpaceX uses real-time trajectory prediction software, basically an AI guidance system, to adjust the tower's position just enough to meet the booster mid-air. The challenge here is completely different from a drone ship landing. A ship can drift and correct itself at sea. A fixed tower can't move much at all. Any weather issue or tiny mistake in the booster's guidance could mean slamming straight into the launch pad infrastructure. SpaceX engineers have poured tens of thousands of hours into simulations to deal with the crazy physics of stopping a booster that's about 3 times heavier than New Glenn and doing it without landing legs. That means tougher re-entry heating, stricter control margins, everything. But the results speak for themselves. 2 clean catches in a row, Flight 7 and Flight 8, with the boosters coming down intact. And if things stay on track, SpaceX expects to start catching the Starship upper stage next year. But why, despite being so risky and complicated, is this approach still so much more impressive, especially for a heavy-lift rocket? First, nobody else on Earth has ever pulled this off. SpaceX is the only company that has actually caught a booster with tower arms. China is trying to copy the idea, but their progress is still pretty unclear. Second, in terms of difficulty, a drone ship landing, like what New Glenn just did, is simply a much easier problem. The ship can drift and reposition over a wide area, which gives the booster more room for error. On top of that, New Glenn's booster is smaller and lighter, so the guidance system doesn't have to fight nearly as much momentum. A lot of experts compare it like this. Landing on a drone ship is catching a fish with a big net, while Mechazilla is catching a falling knife with your bare hands. One has a wide margin, the other basically has none. The tower demands an order of magnitude more precision because it's fixed on land. If the booster misses by even a meter or two, it's game over for the entire launch site. As Elon Musk said on X, shock absorption is built into tower arms. Since tower is ground-side, it can use a lot more mass to arrest booster downward momentum. And that's where things get even harder. Stopping a multi-thousand-ton booster without landing legs means dealing with crazy vibration modes, resonance, and sideways shear forces that can reach into the millions of newtons. If engineers can't master challenges at this level, don't even think about aiming for Mars. But the real magic of Mechazilla isn't just the difficulty, it's the efficiency it unlocks for a heavy-lift rocket. With this system, rapid reuse becomes a real possibility. Imagine this. Right after the booster sticks the catch, the arms lower it onto a transporter, and the whole stack rolls straight back to the production site. In just a few hours, engineers can start inspections and prep work. With New Glenn, it's the opposite. The booster has to sit on a drone ship for days before the ship even heads back to port. That round trip alone slows everything down, which is why Blue Origin admitted in its FAA filings that the initial launch cadence will be only 1 or 2 flights per month. Starship is aiming for something radically different. 3 to 5 flights per week. If SpaceX gets there, the cost could drop to around $100 per kilogram to orbit. That's an order of magnitude cheaper than New Glenn's, projected $1,000 to $2,000 per kilogram, even with reuse. And at that price point, suddenly big missions like Artemis or long-term Mars supply runs become realistic, because they need hundreds of flights, not a handful. And there's one last thing that pushes Mechazilla into its own category: scalability. The tower isn't just designed to catch the booster. In the future, it can catch the upper stage too, making Starship a fully reusable launch system. New Glenn still discards its upper stage every time, which means it can never escape the economics of partial reuse. This is the leap from reusable rockets to industrial reuse. SpaceX is basically building the factory model for spaceflight, where harder engineering leads to better economics and a sustainable path for heavy-lift missions. Overall, after Blue Origin's NG-2 mission, Elon Musk has probably had one big realization. Even though Blue Origin spent years trailing behind, they've been quietly stacking bricks, building momentum, and positioning themselves to one day challenge SpaceX for the title of world's top private space company. Not by blindly chasing SpaceX, but by moving carefully, methodically, with progress solid enough that even NASA has to acknowledge their capability. And the clearest proof, the next New Glenn mission, planned for January 2026, is set to deliver Blue Moon Mk1, the largest lunar lander ever flown, capable of carrying up to 3 tons of cargo and touching down with 100-meter accuracy. It's straight to the moon's surface. They're even planning to reuse the same booster that just landed a few days ago. That's a smart move. It shows Blue Origin can launch, land, and reuse, pushing their costs down and making themselves a serious backup option if Starship keeps slipping behind schedule for Artemis 3. This puts real pressure on Musk, someone who's used to setting the pace. It means SpaceX needs to double down for 2026. And that's exactly what they're doing. Starship V3 is on the way, about 1.5 meters taller than VA2, powered by ultra-efficient Raptor 3 engines, and targeting its first orbital flight as early as January 2026. The top priority is the big one, catching the upper stage with Mechazilla, the milestone that would make Starship fully reusable and capable of flying hundreds of missions a year. Next up is pushing the HLS forward to outmatch Blue Moon Mk1, orbital refueling demos, ship-to-ship propellant transfer, and a long-duration mission proving Starship can rendezvous with NASA's Orion. All of that is required to land 100 tons on the moon. In the end, NG-2 isn't just a win for Jeff Bezos. It's a reminder that America's space race now has 2 true heavyweights: Blue Origin with steady, conservative engineering, and SpaceX with its wild multiplanetary ambition. 2026 will decide who's actually leading, but either